Lesson 2-10, Special Right Triangles. So in this video, we're going to review two of the special kinds of right triangles, the 30, 60, 90, and the 45, 45, 90 triangle. And we're going to use those to help us find the side lengths of a right triangle. So first off, let's review those. An isosceles right triangle is just a right triangle that has two identical legs. That means the side lengths are the same. That would be your 45, 45, 90 triangle. And a 45, 45, 90 right triangle, the length of the hypotenuse is the square root of 2 times the length of the leg. And since the leg is the same, both legs will be the same on that one. And then the 30, 60, 90 right triangle, the short leg, which is going to be the leg opposite the 30-degree angle, is going to be half the length of the hypotenuse. And then the long leg, which is opposite the 60-degree angle, is square root of 3 divided by 2 times the length of the hypotenuse. So let's take each special triangle at a time. First one is the 45, 45, 90. So you see the 45, 45, 90 degree triangle to the right here. The side lengths are both 1. That means the hypotenuse is going to be the square root of 2 times the leg. So I'm going to put a 1 here because it's going to be the side length times the square root of 2. So here we want to find one leg of the 45, 45 right triangle, 45, 45, 90 triangle, where the length of the hypotenuse is 13 yards. So if the length of the hypotenuse is 13, we need to find out what the length is for each of these. So I know that this leg is going to be x, and this is going to be x. This is going to be x times the square root of 2. Now I'm just going to focus in on this part right here because I just need to solve for x because that's going to tell me the side length of the triangle. So if I solve for x, so I'm going to put that over here. So I have x square root of 2 equaling 13. To get x by itself, I have to divide by the square root of 2 on both sides. Square root of 2 divided by square root of 2 is just 1, so I just have x over here. But over here, I can't have a radical in the denominator, so I have to multiply by the radical in the denominator and multiply in the numerator. And that leaves us with 13 square root of 2 on top. And then the square root of 2 times the square root of 2 is 2. Or if you think about it as square root of 2 times square root of 2 is the square root of 4, and the square root of 4 is 2. So the side length is going to be 13 square root of 2 divided by 2. Next, another 45, 45 triangle. Here it says find the hypotenuse of the 45, 45, 90 triangle where the length of the legs are 12. So if I draw it out here, this is 12, this is 12. This has to be 12 times the square root of 2. Because remember, the hypotenuse is always the side length times the square root of 2. So we would have 12 square root of 2. Now, could you figure it out a little bit differently if you did 12 squared plus 12 squared, which would have been 144 plus 144 and got 288, and then found the square root of 288? That would give you the same thing as 12 square root of 2. But that's what's great about the special right triangles. You can use the formula to help you do the math quicker. Next, find the hypotenuse of this triangle where the length of the legs are 25. So again, if I draw it out, this is 25 and this is 25. This means it has to be the side length 25 times the square root of 2. So 25 square root of 2 would be that answer. Another one, find the leg of 45, 45, 90 when the length of the hypotenuse is 39. So again, I'm going to draw the triangle. Remember, this is x square root of 2, and this has to equal 39. So I'm going to do the same thing as the very first problem we did. So I have x square root of 2 equals 39. To get x by itself, I'm going to divide by the square root of 2. And then I have to multiply the numerator and the denominator by the radical. So now I have x equaling 39 square root of 2 divided by 2. Next, we're looking at the 30, 60, 90 triangle, and you can see the formula here. It's slightly different than what I said at the very beginning, but that's only because we actually have numbers for the legs and the hypotenuse. So, and the hypotenuse, I said that this was like C. That means this is going to be half of C, and this is going to be the square root of 3 divided by, it's going to be divided by 2 times a C. Okay, because then if C was 2, then 2 divided by 2 is 1, and all you have left is the square root of 3. So here we're going to find the short and long legs of the 30, 60, 90 triangle, where the length of the hypotenuse is 7 centimeters. So if I draw that out, if this is 7 centimeters, let's just say this is the 60 and this is the 30. So the short leg is going to be half of the hypotenuse. So the short leg is going to be 7 halves, or 3.5. And then the long is going to be the square root of 3 divided by 2 times the hypotenuse. So I have the square root of 3 over 2 times 7. So that's going to give us 7 square root of 3 divided by 2. Next, another 30, 60, 90 triangle. Here we say, it says find the long leg and the hypotenuse where the length of the short leg is 4. So they're saying this one is 4. That means this is half of the hypotenuse, and the hypotenuse then would have to be 8. Because if I double the 4, that gives me 8. And then this would have to be 3 times, or the square root of 3 over 2 times the hypotenuse, which is 8. So that's going to give us the long leg is going to give us 4 square root of 3, and the hypotenuse is going to give us 8. Next, we need to find the long and the short legs of here if the hypotenuse is 10. So if this is 10, the short one has to be half of that, and half of 10 is 5. And then this one's going to be, it's going to be the square root of 3 divided by 2 times the hypotenuse of 10. So that's going to give us 5 square root of 3. So the long is going to be 5 square root of 3. And the hypotenuse is going to give us, not the hypotenuse, they gave us the hypotenuse, the short leg. Short leg is going to give us 5. Now 30, 60, 90. Here we want to find the long leg and the hypotenuse. So they're saying the short leg is 30. So if this is 30, doubling that would make the hypotenuse, which is 60. So I'm going to have 60 for the hypotenuse. And then the long leg is going to be the square root of 3 divided by 2 times the hypotenuse, which is going to give us 30 square root of 3. Next, a word problem. Here it says the length of the sides of a special right triangle are 9 centimeters, 18 centimeters, and 9 square root of 3 centimeters. So that means if I draw a triangle here, this would be 18. This is 9 square root of 3. And actually, let me make this the 9 square root of 3. I'm going to make this one the 9 square root of 3. And then this one would be 9. I know it cannot be a 45, 45, 90 triangle because the two legs aren't the same. I do see a square root of 3 in here. So that tells me this has to be a 30, 60, 90 triangle. So this would be your 60 degree. This would be your 30. And this would be the 90. Because remember, on a 30, 60, 90 triangle, this is the 60. This was the square root of 3. This was 2, and this was 1, and this is the 30 degrees. So that's the basic format. And if I take half of the hypotenuse, that's the short one, and it's really going to be the short one times the square root of 3, which I have 9 square root of 3 here. So the measures of the triangle would be the 30, 60, 90 triangle. So that's our lesson on using the special right triangles to find side lengths of a right triangle.